Hello everyone, today I'm going to go through sequence generation using synchronous D-types. So I've just laid out all of the states that we have available to us. This is going to be a 3-bit circuit. Now let's just say, for example, you want to make, you've got 3 LEDs and you want to make them go like this. And then you want them to go back to this. So you want it to sort of like strobe. So if you were to do that, you should draw a state diagram. So our first state is going to be 1 0 0, which is state 4. This is just an example circuit, by the way, so we have something we can work off. Then the second one, let's say we need 0 1 0, because a 1 would light the LED, wouldn't it? So that'd be state 2. And our third one is 0 0 1, which is state 1. So now let's draw a table. So we're going to go state number. We're going to have Q3, Q2 and Q1. Just don't forget our circuit is our base circuit is going to look like this. And we're going to have a common clock. So this is going to be our current state. And our next state. So now I'm going to put all of the ones that we want. These are our main, this is our main loop. So we've got 1 0 0, 0 1 0, and 0 0 1. And our next state is going to be, we want this to go to there. So this is going to be 0 1 0, and this is going to be 0 0 1, and then we want it to loop back round, so that's going to be 1 0 0. So now I'm just going to cordon this off. So I'm just going to label this our main loop. And then this is going to be our unused states. So our unused states are just going to be floating around here. So we've got S0 is an unused state. S1, we're using S1. S3 is an unused state, 0 1 1. We're using S4. S5, 6 and 7 are unused states. S5 is 101, S6 is 110, and S7 is 111. So there are unused states, and I'm going to put them here. I usually put them in the order in numerical ascending order. So we've got 0, 3, 5, 6, 7. Let's extend that table. Okay, so 0, 0, 0. 0, 1, 1. 1, 0, 1. 1, 1, 0. And 1, 1, 1. And I'm not going to draw the next states here. What we're going to do is calculate the logic for the main loop, and then we're going to apply that logic to the unused states to see where they go. So I'm going to select this, and I'm going to move it. Maybe this way. And I've messed that up a bit. So let's calculate our logic. D2 is going to be 1. D2 is 1 when Q3 is 1 and both of these are 0. So Q3 and Q2 bar and Q1 bar. We could simplify that using De Morgan's theorem as Q2 nor Q1, like that. D1 we are going to do as, it's going to be Q2 or Q1 and Q3 nor together. And D3 is going to be Q1 and Q3 and Q2 nor together. So we have our logic there, and I could draw this on the circuit on here, but I'm not going to. What I'm going to do is I'm going to apply this logic to the unused states and see where they end up. So D3 is going to be 0. This is going to be 0, 0. See, these aren't going to, these are all going to be 0, 0, 0 because this logic only works for these certain states. So we can see that all of these 3, 5, 6 and 7 will lead into 0, and I'll show you that this is not good, because the weird thing about D-types is when you start up a circuit, it can start up in any state. It could be any of these 7 states, or if it's a 4-bit, it could be, 15 states, and you know, and so on. So if 0 is going to lead back into itself, state 0, state 3 is going to lead back into state 0, state 5 is going to state 0, or all of them are going to state 0. So this is what's known as a stuck state. The reason why it's known as a stuck state is because it will never feed back into the main loop, and the main loop is what we want. We don't care about, these are unused states, we don't care about them, we don't want them. So if it did start up in one of these states, one of these 5 states, it will just end up being 0, 0, 0 forever. We want to design a circuit that leads this into the main sequence. It could lead into this part of the sequence, it could lead into this part of the sequence, or it could lead into this part of the sequence. I'm going to make it lead into state 4. And the way we do that is we find what state 4 is, 1, 0, 0, and then we just change the next state on state 0. The next state now becomes 1, 0, 0. So this, when it on the next state, will go to there, and then it will go back into the main loop, which is what we want. So we have to add that to our logic. So that's going to change our logic for D3. And the way it changes that is it will be or, let's do it in blue, or, that was not blue, okay, or nor Q1, nor Q1, Q2, Q3, because it's going to be 0, 0, 0. That's a 3 input nor will be a 1 when all of these are 0. So I don't actually have enough room to do this, so I'm just going to let me just make it really thin. And I've bottled that up a bit. That's nor Q1 plus Q2 and Q3. So now we've got that, we can draw the circuit, because this means that if it starts up in any of these states, it's going to go, they're all going to go to 0 first, and then 0 will go to 4. State 0 will go to 4, like in this diagram here. So actually this is no longer a stuck state, because it will feed back into the main sequence, which is what we want. So now we can draw the circuit. I think that it's going to be a bit difficult to draw because I've made it too small, but I will do my best. So D3 is going, let's just draw these quickly. It's going to be Q1, Q2, and Q3. D1 is going to be Q2 and nor Q3 and Q1. So let's do Q3, Q1. Okay, I'm going to put a nor. Let me just make this smaller. Actually, give me some more room. Draw a NOR gate, 2 input, NOR Q3 and Q1, so we're going to connect Q1 to there, and Q3. and then we're going to have an AND gate with Q2. I'm going to draw it like this. So that's our logic for that part. I'm going to do some different colours to make it more distinct. So for D2 it's going to be Q3 and NOR Q2 and Q1. Let's draw another NOR gate. I'm going to do it this way. Then we're going to draw an AND gate like this. One of the inputs from the NOR, and that's Q3. So it's going to go to Q3. And D3 is the most complicated of the three of these. So it's going to be Q1. I'm going to draw a NOR gate here. We're going to have an AND gate. And we're going to be ANDing together Q1 and NOR, Q2 and Q3. So let's just grab Q1. I'm going to do it in a different colour again. I forgot to do that. It's supposed to be an AND gate. It doesn't look great, but okay. So we're going to grab Q1. Going to navigate through because we got loads of stuff. Q1 and NOR, Q2 and Q3. So let's just do a NOR here. Go to Q2 and Q3. So that's this part of the thing done, and then we need NOR of all three of the inputs. So it's going to be a 3-input NOR, and where am I going to put it? Let's rub this out and put it over here, just to get it out of the way. So we need Q. I haven't left myself a lot of room, but it's going to be Q1. We need Q2. And Q3. And then that's going to feed into this OR. Actually, I'm just going to make it look a bit nicer. And that's that. We've done the logic for this circuit, and it avoids any stuck states, so it works. If I didn't do this, we'd have our stuck states, and that's not good. That's not good design, and it will cause lots of errors. Like it will just be stuck in zero. It will just be stuck doing state zero infinitely if I didn't add this one here. So thank you guys for watching. I hope you understood. If you have any questions, do leave it down in the comments, and I'll reply to them all.